It all depends on the meter. There's a bunch of different meter manufacturers out there, and they've all got their own way of transmitting that data back. So some of them will transmit all the time, or on at least a very regular interval. And others, we ping them and wake them up, and then they transmit back to us. So really dependent, and our system is flexible, so it has to be able to do both. But if you can have similar system on the ground to get the dead spots.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. Today on the show, I'm joined by Ellen Christopherson. She is the CEO and founder of a company called Cleargrid. Cleargrid focuses on aerial collection of data for utility companies. So Ellen's going to be talking a little bit about what this looks like in practice. A few quick reminders before we dive into the episode today. If you haven't subscribed already, consider doing so. And if you are interested in the show notes and resources mentioned in each podcast episode, go along to mapscaping.com/podcast, join our email list, and I send these out on a weekly basis. Okay, let's get started. Welcome to the podcast, Ellen. Really appreciate you taking the time to do this with me. So you are the CEO and founder of a company called Cleargrid. Before we dive into the geospatial side of what you're doing, perhaps you could just give us a brief introduction to yourself and to Cleargrid. What is Cleargrid?
Thanks for having me. Great to be here. Cleargrid is a aerial data collection and analysis company. We specialize in the collection of radio frequency, or RF, data. So a little bit unique that way. And we do this mainly for the utility and energy industries. So an example of this would be we collect smart meter readings for utilities, all their gas, water, and electric. Provide that for their billing systems. And myself personally, I've got a background in aviation, engineering, and utilities. And so enabled me to be in a position where I can see some of these inefficiencies that happen within utilities. It's a great place to be able to include some technology to help utilities and become more efficient. That's where it all came together with Cleargrid.
So I work in my day job, I work for a utilities company here in Denmark, and I completely understand some of the frustrations around collecting this data. So it's one thing to have a meter collecting water data, consumption data. It's a whole other thing to get this data from the meter back to the office so people can actually do things with it, so they can figure out how much water was used, when was the water being used, that kind of thing. It's a huge problem. It might not sound that difficult to some of the listeners, but it's a massive problem. Can you tell me why collecting this kind of data from a plane is a better solution than some of the other solutions that we see out there?
Yeah, you're totally right. It is a big problem for utilities, and a lot of that comes from there's only a couple options to do it. One is you do it manually. So once you have a meter that transmits data, you can drive around and collect the data, but you're still driving down every street. You're going into people's backyards because the trees are in the way. You're still trying to avoid that dog that comes barking at you, and you're still on the icy roads, right? So that's one way of doing it. The other way of doing it is trying to get all these meters to talk to either each other or a central node. And that is quite the feat. It usually takes a number of years before you can get that system to work, if you can at all. And really, it's only applicable for utilities that have a more dense population, so cities. And it's really only something that electric utilities tend to want to look at, because the capital that's required to get this whole thing going, especially on the IT side, which it's a whole nother, you have to overhaul your whole IT system to be able to handle that kind of data coming in. The payback on that has to be there, and that's really usually only for electric utilities. So quite a few challenges associated with that data collection.
Absolutely. I just want to highlight a few things you said there. So driving around collecting data, this is something that the utility company that I work for, that they do, for example. So this assumes a couple of different things. It assumes firstly that you have a meter installed in the house or installed somewhere that has the capability of sending data. So that's one thing. But what we've found when we've been driving around trying to collect data is that signal is obstructed from all kinds of different objects. So that's one thing. The other thing is that oftentimes we're not really sure where that meter is actually located. So one of the things that this utility company that I work for does is they use an address, and they just digitize the meter, say this meter number whatever is associated with this address, and there's a whole bunch of problems associated with that. And I think this sort of speaks to the idea that if these meters, if they do have the capability to send data, why not send it up and fly around and collect it? So I can definitely see it from that side. And I also wanted to highlight this idea that you talked about just before, was a mesh network. So nodes within a network communicating to other nodes that they can reach and then sending data back. So and that is a huge undertaking in setting that up. I could imagine that might come at some stage, and this is the kind of thing we see forming around the idea of smart homes, where homes, can communicate through the local Wi-Fi network or whatever information about the home out to some sort of central hub somewhere. But there's problems associated with both of them. So your solution is to fly around on a plane and collect this kind of data. Can you tell me what that looks like in practice?
Yeah, you're totally right on a lot of those points there. What happens in practice for us is that we get a completely different viewpoint on that meter. And so understanding where that signal is coming from the air is very different than trying to get that from the ground, where you've got all those obstructions, the buildings, the trees, everything in the way. From us on a practical side, we actually have technology that allows us to fly this at 4,500 feet above ground. So we can be way up in the air. We can pass by within a certain distance of that address and pick up that reading. What we actually do is triangulate all of those signals. So every time we hear a meter, we record where we are. We record what the signal strength is. We basically create a 3D map of what that whole RF environment looks like, and it allows us to actually plan our routes in real, in that 3D space where we need to be to hear that meter. So the addresses become less of a problem that way, because we create our own coordinates that we need to hear the signal at.
I'm not a remote sensing expert by any stretch of the imagination, but I'm imagining here that all of these meters need to communicate at a certain radio frequency for you to be able to pick them up. Doesn't that get kind of cluttered with all these meters trying to talk to your receiver at one time? How do you filter that out? How do you recognize one meter from another one?
Definitely gets cluttered. Our technology has to be able to basically handle all of the meters trying to chirp in at once, and sort through that. Each meter has a unique identifier that's attached to the rest of the data. So all of the meters are sorted based on their identifiers. As we process that, we keep that in the database as the main point that we need to associate everything else with. And then that allows us to even tie it back to which utility and keep all that data separated as we need to.
So I understand now that you're probably not that concerned with the actual location of these meters, but can you, as you're flying around, you collect a signal strength from the same meter at different locations? I'm assuming with every pass that you're not always in the same place, and you might fly over a meter and collect it, being a kilometer away, and maybe on the next pass you're 2 kilometers away or closer. Or the point is here that you're collecting the information from different sides. Can you triangulate that back and calculate a location for those meters, or is that location data, is that sent to you via the meter?
The meters don't have location data in them, so we can't tell that from any of the data that the meter transmits. That's any kind of guesstimate on where the meter is located comes from our triangulation. And as you said, we grab that signal data from multiple angles, and so it gives us the opportunity to triangulate the position and gives us a really good idea of where that meter actually is. Depending on the environment that it's in, it also gives us an idea of what's around that meter, right? Sometimes it's blocked in, and so that signal comes only from straight above, and other times it's very wide open, and we can get it from, our record is 190 kilometers away. That triangulation means a lot.
So you're collecting a ton of data here. Not only are you calculating, triangulating the location of these meters, but you're obviously always also collecting the information associated with each meter that they're broadcasting out to you. And you're also, I'm assuming anyway, you're building up these almost like a density map in terms of signal strength for a given area, in terms of radio signal strength for a given area. And what does that data look like, and what can you do with that?
Well, it's quite a unique data set. There's not a lot of data sets out there like this. For our purposes, of course, it gives us where our planes need to fly. So it gives us a smart flight path so that we can collect that information as efficiently and quickly as possible. But on the other hand, you could look at that data and start to understand what what the RF environment in general looks like. So if you're trying to plan a mesh network, you need to understand what's going to interfere with that. And this data starts to give that a very detailed picture. And I suppose you can even look at it from a negative point of view of where those signals are not located, and start to understand maybe buildings in the way, or structures that are impeding that RF signal. So lots of unique possibilities.
Yeah, definitely. And just out of curiosity, do you see any change in that data set over time? Is there any sort of environmental conditions that affect the radio frequency environment?
Yeah, you do see changes over time. Some of it can be other RF signals coming in. So, for example, when you put in a whole bunch of smart meters, or as you're talking about with the smart homes, as you add more and more devices into that home, it actually changes the whole RF environment that we see. And so we every time we fly, we map that, and so we do see changes over time. Other things come in, like there's temporary structures that will be come in, and they'll be there. They'll be there 1 month but gone the next. Surprisingly, we don't have a ton of problems with anything like foliage or anything. There are some RF signals that are very affected by that, but typically the ranges that we work in, we don't see that same struggle.
I have one more sort of question about this data, so please just bear with me for a second here. So I understand that meters at some stage, these collection devices, they have to broadcast a signal. But is that initiated when you fly over? Do you send a message down to them and say, hey, I'm here, send? Or are they just constantly broadcasting? Is this data that people could walk around and collect in other ways if you had some dead areas, or areas that you couldn't collect for whatever reason from the sky?
It all depends on the meter. There's a bunch of different meter manufacturers out there, and they've all got their own way of transmitting that data back. So some of them will transmit all the time, or on at least a very regular interval. And others, we ping them and wake them up, and then they transmit back to us. So really dependent, and our system is flexible, so it has to be able to do both. But if you can have similar system on the ground to get the dead spots. But most of the time what ends up happening is that those systems are designed very uniquely per meter. And it becomes very hard to do this more efficiently and do it for a wide variety of meters. And that's typically a bottleneck that you see on the RF side of things, is they're very specialized.
So we've come a long way in the conversation already. We started off talking about collecting data from the sky. We've moved on to why we might be doing this, why we might collect it from the sky instead of using, driving around collecting it like that, or trying to build mesh networks. There's simply too many challenges there. We've talked a little bit about the data sets that we get out of it. So one of the data sets I thought was really, really interesting was that almost like a density map of RF radio frequency strength over a location, and watching that change the time. I think that was really interesting. And then of course we talked a little bit about the meters and how you can triangulate and calculate the position of them without actually knowing the location from them at the start. Could you give us some use cases now? So we've been talking sort of broadly about meters, but does this apply to any sort of utilities company? Are you using this in other areas of industry?
It's applicable for all utilities, of course, with the assumption that they are using an RF capable meter. Because we've designed this in such a way that it's very agnostic, we have seen a lot of applications in other areas. So, for example, in the energy industry, we're looking at the cathodic protection systems on pipelines, and that's basically their anti-corrosion system. So, a very critical part for their infrastructure to keep it safe and operating properly. And currently, they send guys out on foot, and they will go and measure by hand, and sometimes very remote areas, sometimes dangerous areas to be. And what we can do is apply this technology so that we can grab all that data from the air and monitor the system from the air. Other sensors can be temperature sensors, pressure sensors. We're having conversations with for abandoned wells, having down well monitoring, and being able to do that from the air, pick that up. So lots of different applications.
Yeah, it sounds like it. If we go back to that rust protection use case there, how does that work? So are you sending down a signal, or you receive? Is this another meter where you have a device attached to the pipe that's sending up a signal, or are you sending out a signal from the plane and then collecting the reflection from that? How does that work?
Yeah, so that's what we've done with that is it's a customized industrial sensor that we're using, and we've outfitted it with the communication devices that we use for the plane. And in that case, we do wake it up. It helps with battery life. Being able to keep that out in the field for a dozen years makes a big difference. And so we do wake that one up for the information. But the meter itself is programmed to collect the information at appropriate intervals. So some systems have different requirements on the measurements there, and so that's all programmed in so that it keeps that data until we're in the area.
So this all sounds really, really, really smart to me. I look forward to you guys coming to Denmark. I'm sure you could help us out. And I know that you make a huge difference to the utility company that I work for. So hurry up, get to Denmark. But
well, I haven't been to Denmark, so I'm all for that.
You're more than welcome to come and help us out with our meters here. It would be greatly appreciated. I'd sort of like to move off now and talk about the future, because I can see people having a little bit of pushback around this. We've talked about this a little bit before, but perhaps we could go into some more detail around why a mesh network, why the Internet of Things won't sort of take this over at some stage. Could you talk to that?
I can't see the future, so I can't say for sure that it won't take over. But what we found so far is that this is a big problem, especially in rural areas where you don't get the same connectivity, and it really limits the abilities of these mesh networks to be able to deliver reliable service. And what we see also is that you end up with so much data from the mesh networks. It's too much, and it becomes overwhelming for systems and people. So to be able to really set up a useful mesh network, there's a lot more that has to go into it than just connecting everything together. Now that data has to be channeled and it has to be used properly. And I think that's really actually where the big roadblock is that there's a lot of overhaul that has to be done on the IT side to be able to process that and showcase the information in a useful way for the person on the end there. And I mean, AI is going to come into a lot of that where it starts to handle that. But especially as we look on the utility side, we're not there yet. That's a little ways off.
I appreciate you clarifying that for us. So another thing I could see people looking at this go and thinking, yeah, but we're going to do that with drones one day. Why aren't drones a good platform right now?
Well, right now, the big challenge is on a regulatory side. My background actually includes a lot of work with drones and helping set up beyond line of sight testing ranges, helping consult on the federal level with drone regulations. And that's really where the challenge comes in right now. You think about a utilities territory, service territory, you're looking at a huge area. It's sometimes countrywide, and you have to be able to cover that on a monthly basis. When we look at the regulations for drones, we're most of the time limited by line of sight. Some countries you can do beyond line of sight, but where we're also limited by then is the airspace side. And that's, you've got to be able to enter into right over international airports. We fly into military zones. We fly right along borders. There's a lot of airspace there that drones just aren't welcome right now. And so that's going to be a challenge as well. On the technology side, really what you look for in a drone then is the endurance to be able to handle the longer missions, to be able to cover the ground. And then you're looking at larger drones as well to be able to do that kind of stuff. And then we go back to the regulation side. They're really focused on small drones at the moment, more so than the big drones.
And that makes perfect sense. I'm also assuming that the equipment that you have to have on board in the plane is pretty hungry for energy, for power. And I'm assuming that drones at the moment, they simply can't have a battery big enough to power both themselves and the equipment needed. Would that be a correct assumption?
That would be that we need quite a bit of power to be able to really accommodate the incoming data flows. And so you end up with, you need a drone that's either not battery powered or that it's got a very large capacity for that to be able to handle the endurance at the same time. So we do actually operate Diamond aircraft, and the DA-42 has a full conversion kit to unmanned. And so then you end up with a plane that is capable of providing the power necessary for this, has the endurance. Unfortunately, we land back at the regulation roadblock.
So my last question for you today, before I let you go, is around marketing. So this is a geospatial podcast, and this is going to seem a little bit funny, but just bear with me for a second. So when I look at your website, and after listening to you, are you in fact a remote sensing company?
Yeah, you could definitely say we are. We specialize in the collection of data from afar, and we happen to do that for the RF side of things, which is very applicable for utilities. But it's definitely a remote sensing company that way.
Yeah, and so this is one of the things I noticed. I was looking at your website and I was thinking, wow, this is actually a remote sensing company, but nowhere does it say a remote sensing company. Can you tell me why you don't use that language?
If you ask me, when you say what does a remote sensing company do, it's very vague, it's very broad, and it doesn't really give, if you're looking at a potential client, it doesn't give them anything to go on for whether or not they can use your services. And so we've tried to be a little bit more specific on some of those services, and just make it more accessible to people who aren't in the remote sensing industry to understand what we can offer.
Yeah, and the reason why I'm asking you those questions there, because oftentimes I fall into this trap. So I see myself as a technologist. I love the shiny, tech stuff. Love it. I think it's fascinating, and I want to apply it whenever I can, kind of thing. But I've learned with time that I don't need to overwhelm people with the technical side of it. So I think it was really great here when I looked at your website and when I hear you talk, you're very focused on the mission as opposed to the medium that you're using. What is the mission? The mission is to help these companies out to collect their data. It's not so much the technology that you're using to do it, although that plays a big part. And I thought that came across really clearly in your messaging. And I think a lot of us in the geospatial industry could learn something from this. So, of course, you're talking to other businesses. There'll be listeners out there that are talking to decision makers in their organization, and they might be very, very tempted to jump down in the details and the weeds of things and start talking about the technologies that are underpinning the solutions they're talking about, as opposed to lifting it up and saying that we're talking about the mission is to solve X, Y, and Z problem, not to sort of focus on the technology. And I thought you guys at Cleargrid have done an amazing job with that. So I just want to take a second to highlight that.
Thank you. Appreciate that feedback.
You're more than welcome. And thank you so much for joining me today. Really appreciate it. I've enjoyed the conversation. I look forward to seeing Cleargrid here in Denmark.
Absolutely. Look forward to being there as well. Thank you very much.
You're welcome. Just before I let you go, where can the listeners go to reach out to you if they have any questions? Where can they go to find out more?
They can go to our website. It's cleargrid.io. If they have any questions, there is a form there that they can fill out, or they can contact myself, ellen.christofferson@cleargrid.io.
Thanks again, Ellen. I really appreciate it.
Thanks.
So I really hope you enjoyed that interview with Ellen. Just a quick reminder, we do write reasonably substantial articles about each podcast episode, and they're available at mapscaping.com. So if you want to revisit any of the things we talked about, go along there and find the episode. And if you would like me to send you an email with all the notes, links, and resources mentioned in the weekly episodes, go along to mapscaping.com/podcast and sign up there. This is completely free. Sign up. You can also sign up and receive the links and notes from one episode and then unsubscribe if you like. There is no hard feelings from my side. And that's it for another episode of the Mapscaping podcast. Thank you so much for tuning in again this week. I also really appreciate the people that are reaching out on LinkedIn. It's a real privilege to connect with you, and I'm really enjoying the engagement there. So if you haven't done that, feel free to do so. I'd love to see you there. Okay, we'll talk again next week. Bye.